All right, well, welcome everyone to the May 2021 meeting of the Mississippi PowerShell User Group. Tonight we have Microsoft MVP, Jaap Brasser, with us, and he'll be presenting Level Up Your PowerShell Experience, Getting Started with Pester. Take it away.
Thank you very much. And I hope I represented the Mississippi correctly by getting a picture of something that's actually the Mississippi, because I Googled for pictures of the Mississippi, and this looked like a river, so I figured this was this had to be it. Cool. As mentioned just before, feel free to interrupt me and ask questions. Let me also open up the chat. So I like to keep it interactive. It's that keeps it a bit more fun. So there we go. So before we continue, my name is Jaap Brasser. These are my contact details. I won't go into too much detail about myself because that's arguably the least interesting part of this session. So let's dive into the session itself and what my idea behind this session is. So when I started talking about speaking at the Mississippi User Group, there were a couple of topics that came to mind, and we selected Pester because we figured most people are either familiar with what Pester is, but not everyone might have gotten started with Pester yet. So there we go. So my idea of the session was to not go extremely code heavy, as I usually tend to do, and focus a bit more about the process and my journey with Pester and my journey with testing in general. Because if you would have asked me a year ago what I thought were good testing practices, would be different from what I'm thinking now. So we'll talk about the concepts, about what Pester is. Obviously, there will be some examples, but it will be light on actual code and demo, and then we'll leave some time for discussions at the end. So I hope that matches everyone's expectations. So with that out of the way, let's get into the why we actually want to be testing and why we're going to go to the trouble of creating our first test or our first series of tests. So why are we testing? Well, the first reason why is because I know myself and I know the kind of code I write, and sometimes I don't know what kind of code I write. So when I'm coming back to old pieces of code that either I've shared on GitHub or something that I've created, it can be a couple of months ago, it can be a couple of years ago. I have no idea what my intention was when I wrote certain code blocks. If I was in a good mood, I wrote some comments there, but if I was trying to get a job done quick and dirty, there might be no documentation or no explanation of why I'm doing certain things. So that is one of the reasons that unit tests can come in, because you can validate it when you execute your code, when you make changes to your code. By running your tests against it, you can validate that still the right output is coming out of your command and it's still in line with its original design. So as I mentioned, I use it for old code. I use it to weed out bad code. So bad code can be a variety of things that would qualify it as bad code. One of the things that Pester can help with quite a bit is with enforcing coding standards. So you can use Pester to see if, for example, if no aliases are used, if it matches up with the PScript analyzer rules. So that way you can make sure that you don't accidentally leave an alias in there, or when someone else is making changes to your code, you can validate that everything is the way you would like to be, and that way you can exclude weird code and in my case, my own code. And then it brings you to the part of having other contributors. So this is where unit testing and specifically testing with Pester becomes quite powerful and quite useful. And the reason for this is I'll circle back to where I came from. So I inherited an open source module that was hosted on GitHub, and there were a lot of contributions coming in from the community. But one of the challenges that I had was I inherited a lot of old code, so from the previous example. And my challenge with that was if someone made a change to it, or if I made a change to it, I didn't always exactly know if the code was still functional. I mean, I could run it on my system. I could have a couple of test commands for myself just to validate that it appears to be working, but I didn't have anything proper in place. So one of the things that I did when I inherited this project was to make sure that there were actually unit tests there and that there were integration tests there, so I could validate that. And what that enabled me to do was to go from this, a pull request came in and it was discussed with Jaap, so it must be good, to this, just having a suite of tests available, running on different operating systems to validate that the code is not only still functional, it still gives the correct output, but it also runs on different platforms. And the neat part about it is that once you've invested the time into making sure that you have these tests available, making sure that that you have a pipeline set up that runs your code and that validates that the changes that in this case on GitHub were pushed in, they still your code is still going to function the way you want it to. So this is a GitHub example. The good thing about Pester is you don't need to use CIs. You don't need to have your code on GitHub. You can run it locally as well. So there's no necessity for that. So the reasons, I'm not going to go over these all, but my main reason is to make sure that to ensure that I can collaborate with others with my code, to make sure that whenever I make changes, those changes are going to be reliable, not going to be breaking my code, and I want to enforce a certain level of quality of my code. So there was a brief intro into why we want to be testing in general. So let's get into Pester and some of the language concepts that we have inside of Pester and what it means if you want to get started with writing tests. So when I was taking a look at images for Pester, I found this one. I found this one interesting because to annoy someone by asking them something many times, I figured it summed up what I use Pester for most of the time, because whenever I make any changes to my code, I will run either a test or 1,000 tests to validate that either my script, my function, or my module is still going to function the same way. So it's a well-chosen name for the product. So the first thing to note is that Pester is a DSL, so it's a domain-specific language. So what that means is that Pester has language concepts that are not available in the PowerShell language. This is good in one sense that it can enable you to write Pester tests in its own specific language. The other end, it also means there has to be an investment into learning that DSL to be able to understand it. The nice thing is that it's all very human readable, but the downside, of course, the additional investment in time. So we'll briefly go over a couple of the language concepts there. So first thing to note is we'll talk about the first three. So these describe the context in which the tests are running. So like in PowerShell itself, you have different scopes in which your code run. So if you have a module, then the module is the top scope. If you have a function within the module, anything you run within that function is contained within that function. And if you would have a script block in that function, that would be the smallest piece. So it's similar with that in Pester. So you have the Skype block, which is the top block that encapsulates either one or multiple context blocks, and then it is are the blocks in which you would put the actual tests. Most of the tests you would validate whether the output is going to be what you think it is, and instead of using the comparison operators like you would in regular PowerShell, so a comparison operator would be -eq, you use the shoot in combination with B. The last concept would be mocking. So mocking is used to create a fake function to be able to isolate what you are going to test is going to be the functionality of your function, your module, rather than testing external factors. So an external factor could be if you write a function that gets information of the internet, then you could mock that function and just return a web object or return a single result, just so you can validate that your function is going to go through that flow of receiving that input and processing that the way you would expect it to. And in order to be able to run Pester tests, there's multiple ways of doing this. My favorite way is just to do it directly from VS Code. If you have the PowerShell extension installed, you can directly share. You can directly start your Pester test by clicking the Run button if you are in a script file that contains Pester tests. The neat thing about using invoke Pester is that you can set the level of detail of what you want to see. You can change what kind of output it is, how the output is displayed. So you can choose, for example, to output as XML. And it also provides you with an object at the end of the test. So just a PowerShell custom object that contains all the results and allows you to dive even deeper into the results of your test. So what does it look like when you're getting started with Pester? So I mentioned that you have a Skype block. So in this case, Skype followed by a string. The string specifies that specifies the name of the Skype block. This is something that's displayed when viewing the results of a test. So then inside the Skype block, in the second image to the right of that, you could place your test directly in the Skype block. You could also continue with that, create a context block, and then within that context block, you can either put one test in the it block or a selection of tests inside there. So that's basic scoping and also the way you can organize your test. So a common occurrence for me would be if I'm testing a certain function, what I would do is I would create the Skype block for that function, and the context I would test different functionalities of that function. So for example, in one part I would validate how it would operate if it's getting back. Let's go back to the example of something that retrieves information from the web. One part of my testing cycle would be, what does it do when it gets back the correct information? So then I'll walk through that flow. If there's if or else statements in there, I will make sure that all of those parameters are hit. So you'll be able to go through your entire function and ensure that you don't just test one scenario, but you test all the different flows to your function, to your script, to your module. And I organize that using context blocks. Cool. So Pester tests in general are named .test.psm ps1 to indicate that there is going to be different language concepts, and because you can't just run them as regular PowerShell files. If you just execute it, it would fail on the Skype block because it's not a recognized command within PowerShell. I mentioned that we can run the code. We can run Pester directly from VS Code. Use it with invoke Pester, or use it in your favorite CI tool. My current favorite for anything I do on GitHub nowadays is GitHub Actions. But when I got started, I initially worked with Azure DevOps more, but since the shift seems to be GitHub Actions and most of the development effort seems to be going in there, that seems to be the right place to focus your efforts. And I know that Justin did some cool work with that as well. I do believe it was GitHub Actions, but not entirely sure. So when building your Pester test, there's a couple of things to keep in mind. So you'll have to look at your script in the sense of what your script, your function, what are some logical paths, or what do I want to test? And this is where it gets a bit abstract, and also the thing that I struggled with when I got started with Pester. That is the first thing was, why would I want to test anything? Because I can run my code and I can see that it works. So that's good enough for me. But once you get past that, first hurdle, it becomes important to identify the flow of your script, identify the different ways that that you could run through your script, and then based on that determine what you want to test. So if you have a lot of nested if-else statements, or there's a lot of different ways that your code can flow through your function, then determine what would make sense to test. Does it make sense to test everything? Then testing everything might be a good option. And if that's not the case, then just pick the most important, pick the most common scenarios and test those. So then we get to the second to last step. So actually building the test and getting writing the Pester test. Once you've written those, run them. If they pass, good. If they fail, better, because that's a learning experience, and you'll be able to dive into why it isn't working. Once you have your test set up, everything is green, then start intentionally breaking your code and see if your code is see if the test actually capture the fact that it fails. If none of the tests fail when you break your script or your function, then you know that you're going to need additional tests, or if it's just something silly, you might choose to ignore it. But in general, it's a good idea to make sure that you cover common breaking scenarios. So with that, I'd like to see if there's any questions yet. It seems to be good so far. So then,
yeah, looks like we're good so far.
Yep. So with that, I'll switch over to VS Code. Thanks, Glenn. I'll keep it going. So let me know when you can see my VS Code. Let's see.
Yeah, it's up now.
Yep. Great. So are the colors okay? It's nighttime for me, so I definitely changed it to dark mode for myself.
Looks good to me here.
Excellent. Cool. So the first thing, we're going to take a look at some sample Pester tests. So these are relatively simple. So what we're doing here is we're just checking if my computer is a 64-bit system, if the process that's running this command is 64-bit, and we want to see if it sparkles. So I mentioned that we can run the test directly from VS Code. So we can click Run Test, and we can see that all tests pass. If you've worked with Pester before, in previous versions of Pester, the default was to display all running tests. Now that is no longer the case. So if you want all details, we have to manually execute it or change the defaults. In this case, I'll manually do it. Output. And output. So we have a couple of options here for the output. So in this case, I'm going to go for detailed because we want to make sure that we see every test done. And we can see that all the tests pass. So can validate this by running this. So you can see we have the machine name. The machine name is actually unicorn. So if we would change this from unicorn to a lion, for example, and we'd run the same tests again. If you'd run the same tests again, you can see that we can see the notation with a minus instead of a plus, and we can see that there's different strings here. So it was expecting a lion, but it got a unicorn. So it's in case of string comparison, it can be quite easy to see where something is going wrong and what is what should be done to fix that. All right. So this is this would just be testing against my machine rather than against code. So if we are going to go take a look at some code. So in this case, I have an example function. So my example function is going to be quite simple. So what it does is it will get the memory of my system. So running get memory, we can see it will return 64 GB. So if we run get sim instance, just to see what kind of output we get there, you can see that this just gets all kinds of information about my system. And what we do within this function is we're going to get the total physical memory and just divide it by the amount of gigabytes. So a simple test for this function would be to take a look and see if the output is going to be what we think it is. So in that case, we could just do memory should be 64, and we have to make sure that we get it. So there we go. So now if we run this, you can see all the tests pass. Let me just get the correct test out there. You can see the detailed output once it fails as well. So you can see now we can validate that it has 64 GB. But what I mentioned before was if we want to take a look at the flow of a function, and if we want to ensure that this is going to provide the right output regardless of the kind of system, then just checking the fact that it returns 64 GB on my system, that doesn't tell us that much. So this is where we get to mocking. So we have the get sim instance commandlet. So this gathers information from my system. And by using mocking, we can mock this commandlet and have it return any kind of output that we want. So that is what we're doing in the second example. And what we're doing here is we're taking the command get sim instance, and we're going to have it return only a PS custom object that returns a single property, that is total physical memory, because that is what we're using in the get memory function. So by setting this one to 64 GB, running the test, we can see that it works as expected. So what we could also do is we could also ensure that if it doesn't return that amount, that it would fail. So see, put it in a different block. So, for example, if we're going to do here, test failed output, you can see now that we're going to mock it to 32 GB. Oh. I think I'm command. So there we go. So if you do it with not, we can see that it fails. So if you do it here, we can see that it got 32. So we can see that with different output, we're going to get different results, even though my system is 64 GB. So we can use this concept to abstract external commands away when we want to be testing our own functions and our own commandlets. So on the other side of the fence, so what if we start breaking or adding additional functionality into our example function? So, for example, someone would think it's a good idea to move the asInt because, I don't know, doesn't seem particularly useful. So I've just saved with this function, load it up again, going to run this test, and it's still the same amount. There we go. Should be exactly 64 GB. Interesting that it still passes that one. I would have expected it to fail due to it not being exactly 64. Anyway, I'll change it to megabytes instead. So now we're definitely going to get a different result. So I'll make it an integer again. So load that one up, run this same test again. So we can now see that the test would fail because we accidentally intentionally changed the output from gigabytes to megabytes. So other things that we can do is we have this function. We know we want to return a PS custom object. So we could create additional tests that will test if the result of this function is going to be a PowerShell custom object, or if you would add additional properties there, that you would verify that all the properties of this object are going to be there and are going to be filled out when you expect them to be filled out. If you have different flows in here, that you would go to that commandlet and ensure that that is all tested. Cool. So with that, switch back to this one. So that takes me back to where I've been with Pester and what my biggest takeaways are there. So initially, my biggest struggle was to figure out what I wanted to test, rather than determining what would make sense to test. So in the case of when, for me it depends what the purpose of a project or the purpose of a piece of code is. So if I have a project that I work on for myself for an afternoon, and I know that I'm going to be the only person using it, and I don't really care about it still being functional 6 months from now, in most cases, unless it's potentially very destructive, I wouldn't bother with testing and ensuring that I have unit tests and integration tests. That brings us to the what. So unit tests and integration tests. I've skipped over it during the examples that I gave, but the initial test I was showing was just showing the initial tests were just testing if my infrastructure was the way I expected it to be. In the second example, I've showed how you can abstract parts of your function away, so you can unit test and test on specific components inside your code. And then it gets to the fact, like, how many tests do you want to write? So if you have complex functions, then it's logical that you have more tests, but how many tests is too many tests? That really depends on the level of detail that you want there. And then we have the environment. So do you want to ensure that your code can run cross-platform, or is that not important for you? It goes beyond just testing cross-platform, because there's also different versions of PowerShell. The biggest two are, of course, PowerShell and Windows PowerShell. So anything after PowerShell version 6 is limited in some ways, as not all the Windows-based commandlets are there. Likewise, using Windows PowerShell will limit your ability to run web commandlets, as they were less than ideal on Windows PowerShell. They were mostly improved when we moved to PowerShell 6. And in case you have code that is for which it is critical that it runs on a specific operating system at a specific patch level, with a specific version of .NET, you could integrate this into your unit tests, and most likely, if you get to that level of detail, you would integrate that into your CI pipeline. Because there are some scenarios where if you have either very old versions of PowerShell or old versions of PowerShell at different patch levels, that certain commandlets or certain functions give different output or don't run, or if your code is using external dependencies or is using .NET classes, the classes might not be available if you're on an older .NET version, or if you're on .NET Core, then that class might not be available at all. So those are some of the considerations. With that, I would like to open it up for questions and discussion.
Well, thank you for the really good presentation there. I do have one question.
Yes.
Maybe not directly related to Pester, but what is the theme you're running in VS Code?
That is, let's see, I think it's Synthwave 84 or Synthwave Fluor machine. I'm using them both interchangeably. I don't know which one it's set to at the moment. I saw a question from Jeremy. Is this Pester 5? Yeah, it's Pester 5, but the tests that I was running in the demo, they would work on 4 and 5. There have been big changes going from PowerShell 4 to PowerShell 5. So if you go tests on PowerShell 4, there's on Pester 4 to Pester 5. If you go to any tests on Pester 4, you probably have to make changes to your Pester tests in order to get them working. Either that or be lazy like I've been and just force my CI to use Pester 4 as the testing engine. I see Justin talking. I'm not sure if Justin is talking to us.
I'm just yelling at my dogs.
Okay. Well,
being
perfect.
goofs.
It's all good.
I see some typing in the chat. So Francisco mentioning that he doesn't think that he used Pester very much. Vester is indeed interesting. I know that Erwin has also done a lot with infrastructure testing. So there's been some examples of people running Pester test against their Active Directory, taking a snapshot of what their Active Directory looks like, or what their expected state would be, and then running that every day. And if there's a change, then showing that. Similarly, people have built those frameworks. Build those frameworks for Azure as well, and Vester using Terraform to test that. Question for documentation. Yep, that's a good documentation, the official Pester documentation. There's a lot of blog posts out there as well. Usually what I do.
Sorry.
Yeah.
Ensure that you're looking at posts about Pester 5 if you're just getting started, because there is a big difference in mostly in terms of like there's this new thing called a discovery phase, and it's really nice. Like once you learn about it, it makes it really nice to like repeat tests that you don't have to write them over and over again. You use for each test. But if you've written your tests in 4, the problem is that a lot of the statements that you might be doing currently to like set up your tests are actually happening in the discovery phase. And so all of a sudden your test break, what you have to do is you have to wrap those in before each or before all statements, which are just brackets, just like the iter describe blocks. But what that does is that pulls them forward so that they execute actually in your testing phase and not the discovery phase. So I mean, I think that's just one thing I'd point out is that if you're and the official docs are really good at covering that. But if you're looking at old videos or anything like that, like if they're talking about Pester 4, just know that the stuff that they're showing may not work correctly unless you do them on Pester 5. And the biggest thing you need to know is that aspect. If you write tests that also have argument flags, like you can make tests where you can like specify a server name and it'll do that like along with the parameters. That the way that works has changed. There's now this concept of containers and configuration. So like those are like the biggest things that if you're moving from 4 to 5, or if you worked with Pester a little bit and you haven't tried Pester 5 tests, you upgraded to Pester 5 and they all broke. Like those, that Netlify, the actual official documentation covers it really well. And also Jacob, who writes Pester, the guy who does Pester, is really frequent in the PowerShell Discord. So if you go over to the Pester testing area, if you just ask a question, usually the guy who wrote it will respond to you. He's really good about that. So keep that in mind.
Yep. Yeah. Jacob is a great guy. Also used to be a PowerShell MVP, but then Microsoft snagged him, and now he became a blue badge. Yeah, the only other thing I'd like to add with that, a big difference was also with mocking, or at least that's something that that very much affected me when I went from 4 to 5. In 4, you could just mock in the Skype block, and it would go down for all the it and context blocks below it, and that's no longer the case in 5. So you have to specify it in the it block.
I actually haven't had that yet, but we can talk about that separately. Like,
Oh, okay.
if you look at my secret, like, so all of my secret management modules that I've built, they all have Pester Tests. My press module has Pester Tests. If you want to see some examples, there's a lot of them out there. But you'll see in those that the mocks are up in the describe block, and in some cases, like in like even the before each and before all. So, but
Okay.
but there's
Well,
some things, like especially if you're like testing modules, there's a dash module name parameter that, like, in terms of like getting it into the module scope, that's stuff that's new that you have to be very careful with. It can be really tricky, and took me a lot of troubleshooting to get to work.
okay, that's disregard my remark until further notice in that case. So Glenn notes that he's happy with the direction. Yeah, painful, but worth it indeed. I did find mocking to work more pleasant in 5, but let's see, documentation. Yep.
So I think there was a question about mocking and it being difficult to understand there. Yep.
Oh, right. Yep. I'm not sure if it's a question or a comment, but yeah, mocking can be difficult, especially if you're working with different modules and different scopes. But the baseline is you try to especially when you're writing unit tests, you're trying to isolate the fact that that your function or your script is going to is what you're testing, rather than the output of other external functions. So if that's the way you feel mocking it, that helped simplify it for me. Well, then your personal experience response is that it's his personal experience. That's also my personal experience. Mocking is hard to get your head around, especially when you're just getting started.
Your actual mileage may vary.
Yes. So the other one, how do I use Pester to test functions that are useful only within Orchestrator scripts? Is Orchestrator a product?
I think what he means is, like, let's take an example. Like, you have a function that, like, for instance, creates a user, and you've made that as like a tool that creates it specifically for your organization. Like, it reads from a CSV or reads from an HR system and creates the user, and then you call that from a larger orchestrator script that, like, runs on a schedule or pulls information from somewhere else to then call that function. And so what I would recommend is that where that's useful is that this is where, like, some of the mocking comes in, is that you can test that, again, the inputs match what you want your outputs to be. So if you have a function that, like, creates a user, you can give it to it with a CSV, but then you can mock that CSV process of just giving it that fake information, like giving it a user named Pester with a last name Pester. And then you expect the object that comes back out has a last name of Pester, or you expect that when it invokes the new AD user command, it invokes it with these very specific parameters, and those parameters have these particular things. And you can do all that with mocks. Like, you can actually mock, like, the new AD user command, and rather than have it actually run it, have it just, like, fake that it ran it and, like, return nothing, or return fake an error that occurs, and just make sure that the logic in that function works. And then once you've got that tested, then you don't have to test that again. And then you can just, your orchestrator function test can do the same thing while calling that module with all those mocks. And again, you can make sure that now your orchestrator logic flows, that it calls that command 3 times. And when it calls that command, it has these parameters coming in. So that's where like I find it useful. If you look at like my secret management KeyPass module or my secret management Chromium module, you'll see like that basically everything in there are like little helper functions like get secret, set secret, etc. And then there are some larger orchestration functions like registering a vault. And you can see in there like how certain things are broken out to be mocked because I don't want to actually test with a live vault, or I don't want to test against, Azure Key Vault directly because I may not have an account available, or I want somebody to be able to test that stuff offline, like if they're trying to change something and make sure when they change it, the logic still works. So those are all like really good examples of like how you can test even sub functions or subscripts that aren't your larger function. But typically, like that's not where I'd recommend you start testing. Like the easiest test you can write, in fact, the first test I almost always write is it in quotes works, and all it does is call the function. And then when I run it, I can run test in the VS Code like CodeLens or something. It just runs the command as long as it does an error. Like even if it returns whatever it returns, you don't have to do the should match. Just as long as it returns and does an error, then the test passes. And then you can, that's just, it works like that. So when I'm running it the first time, it's like, okay. And then I build on top of that. It's like, it works. And, this property of the object that came back should be true. And this last name on the object should be Pester. And then you can just build on that test and refactor and keep building it up until you have like a really nice test that covers everything. But your first test doesn't have to be this long detailed thing with all the shoulds right off the bat. It can just be, it works. And then what's nice about that is that when you go through that testing, you can click that debug test button if it doesn't work and step through your function, see, oh, okay, I see where I went wrong. And then, okay, it's because that's where I went wrong, I'm going to write a test for that so that I never do that again. And that way, like as you're writing your code, you're actually writing your tests at the same time. And when you're done, all that troubleshooting work that you did doesn't go away, because now every time you run your tests, you're basically going through all those troubleshooting steps you already did, as well as going through them for anybody else who's going to use your code. So that's really nice. You can find a lot of subjects on this called like test-driven development. I kind of call this like halfway between test-driven development and others, because test-driven development says you write all the tests first and then you write the code. And I never agree with that because I don't know what I'm going to write. And so what I recommend is like something in somewhere in between. And so where you kind of like write your code that you need to do and then add in a little bit of test and then kind of iterate with it.
Yeah, I definitely agree with that sentiment. I've tried test-driven development. When I got started, when I inherited the project that I mentioned before, I thought I wanted to do test-driven development. I quickly found out that I didn't want to do test-driven development. I also think that my coding style is a bit too chaotic for that, so I could never write the test and then have functional code after that. So for me personally, it definitely didn't work. Another question or comment. I imagine that, yeah, you have had experience with old code you inherited, but it's hard to write Pester tests for it. Definitely the case. If you want your code to be testable in a proper way, you might want to add in more functions, and sometimes you might actually want to add in functions for the sole purpose of being able to test your code better. So yes, that's the case. You end up rewriting your code to make it more testable. Giving up the idea of doing tests on old code. Great advice. I definitely didn't write a code for some test for some of my old code. I've repositories going back more than 10. Well, the code goes back more than 10 years. It hasn't been on GitHub for 10 years. Yeah, I don't think I will ever write tests for that unless I feel particularly motivated. Yes, definitely look at Justin's test. That is good advice. Other comment, the balance and struggle of building tools versus making tools that conform to the style and proper standards. That brings you back to the why and the when of testing. What is the goal of your project? I would say if it's something that is going to be in the hands of someone else at some point, then I would definitely write tests for it. If it's something that I create because I think it's fun, then most of the time I don't.